Okay, guys, welcome. In this video, we're going to talk about finding the number of subsets of a set. Okay, so for the motivating question here, we're going to ask ourselves, what is the number of all possible subsets of a set that contains n elements? All right, so to answer this, let's just start with some small values for n. So if n is 0, meaning that we have a 0-element set, which of course is just the empty set, well, we know that the empty set is always a subset of any set. So we at least have the empty set, but there's nothing else. So there's one subset. Now, if we have a 1-element set, so we just say we have one element that we'll call A, well, we again get the empty set no matter what. But we could also take the set to be the set itself, right? And that, of course, would qualify as a subset. But those are the only two. So it looks like we have two possible subsets there. Now, if n is 2, we have a 2-element set. Here we'll assume that the set contains A and B. Then I can have, of course, the empty set. I could have the set that only contains A, the set that only contains B, and then, of course, the entire set itself. So that would give me 4 possible subsets. And then finally for 3, so I could have the empty set, I could have each one of the elements by themselves, I could have all the possible 2-element sets, and I, of course, could have the entire set itself, right? And it looks like there we're going to get 8. So it looks like if we were to do 2 to the power, where the power is the number of elements we have, it looks like that's going to work at least for these small examples, right? So it appears that if a set has n elements, we can make 2 to the n total subsets. And of course, this is going to be true. Now, if you have a set with n elements, which I'll just call a sub 1 through a sub n, what you really have each time is you have 2 choices to make about each element. You can either include it or not include it in a particular subset. So you have 2 choices for, say, the first element. For the second element, you can either include or not include again in a particular set, so you have 2 choices. And you can continue in this manner for all n elements, which is going to give you 2 times 2 times 2, n times, or 2 to the n choices. And of course, this gives us a theorem about the number of subsets of a set. And that, of course, is what we've been saying, is that a set with n elements will have 2 to the n subsets. Now, for an idea of the proof, you can use what's called a decision tree, right? And how this decision tree will work is, let's just look at the first element, okay? Now, S would just be any particular subset that we want to make. Now, for the first level, we say, are we going to put A1 into our subset, right? If we say yes, then we've included A1 in our subset, and we ask ourselves about A2. If we say no, however, we're still doing the same thing. We're then moving on to A2, and we're asking ourselves, are we putting in A2 into our subset yet or not? And then, of course, each of those will have different outcomes. So you see here that you have 2 outcomes. Here you have 4 or 2 squared outcomes. And then in the next level that's not shown, you'd have 8 or 2 to the third outcomes. And then you just keep doing this until you get to the nth element. And of course, that would be 2 to the n, right? And to find any subset, you could use this diagram to list which elements we would or would not include, right? So this will cover all of the cases, and we know that there's going to be 2 to the n possible choices. Okay, so now that we've talked about subsets and all possible subset, we can now define the power set. Now, the power set of a set A, which we'll denote P parenthesis A, is the set of all subsets of A, right? And of course, we could list this as the power set of A is the set of all sets B, such that B is a subset of A, right? Now, we know that if we want to find the cardinality of the power set, well, the set of all subsets, of course, will be 2 to the n. right? And n, of course, is the number of elements of A. So as an example, let's list all the elements of the power set of A, where A is A, B, C, D, and E, and we'll use theorem 1.3.1 to confirm that we didn't miss any, right? So now A has 5 elements. So how many does power set of A have? Well, the power set of A will have 2 to the 5th, which is 32 elements. All right, so we should be able to come up with 32 subsets. Well, of course, we have the empty set. We're going to have each of the one element sets. So we could have A, we could have B, we could have C, we could have D, and we could have E. Well, then we could have all the 2 element subsets. So we could have A and B, we could have A and C, we could have A and D, and A and E. Could also include B and C. I don't want to do B and A because I already have that one. I could have B and D and B and E. I could also have C and D, right? And again, I don't want CA or CB because I've already listed those. So CD and CE. And then I could also have DE. Okay. Now, of course, I'm out of elements there, so we can now move on to the 3 element set. So I could have A, B, C. I could have A, B, D, and A, B, E. I could have A, C, D, and A, C, E. And it looks like the last one, starting with A, would be A, D, E, right? So we sort of move in this systematic manner, right? Sort of just going in order, right? So I guess the next one here, I would need a B, C, D, and then a B, C, E, and then I would have a B, let's see, a B, D, E, right? And then it looks like the last one I could have would be a C, D, E, last 3 element set. So now we could do all the 4 element sets. So it looks like I could have an A, B, C, D. I could have an A, B, C, E. I could have a B, C, D, E. And I think that would be all of our 4 element sets, right? And then it looks like, let's see, no, I could also have, I missed A, C, D, E, right? Could also have that one. And then, of course, I could include the entire subset itself, A, B, C, D, E. So now comes the moment of truth. Let's see if we got them all. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So it looks like I'm missing one here, right? So let's see. So did I get all of the 2 element sets? I think I did. I think I might have missed one of the 4 element sets, right? So I have A, B, C, D. I can have A, B, C, E. Could I have, yes, I am missing one of the, because I could have A, B, D, E. That's the other one. Okay, so that's the one I'm missing. Right, so once you get some larger subsets, of course, it's going to be easy to miss one, but you can use our theorem there to validate that you do have all of your possible subsets. All right, so that concludes this video on the number of subsets of a set. I hope you enjoyed, and I will see you next time.